Hello everybody! Today we will be talking about the graph of product concentration for enzyme-catalyzed reactions with non-competitive inhibitors. Here are the past graphs for the product concentration based on substrate concentration for enzyme-catalyzed reactions without any inhibitors and enzyme-catalyzed reactions with the presence of a competitive inhibitor. If you haven't watched the non-inhibition graph of product concentration video or the competitive inhibition graph of product concentration video, we highly recommend that you start from the non-inhibition video to the competitive inhibition video, because during this video we'll be actively comparing the graphs to each other. Similar to the last video, we will qualitatively visualize the process of adding more substrate to a reaction with an enzyme and non-competitive inhibitor. We will imagine a scenario with two requirements. First, that there is a constant concentration of inhibitors and a constant concentration of enzymes, while the substrate concentration is the only varying quantity. Again, this is because the substrate concentration is our independent variable, and we want the inhibitor concentration and enzyme concentration as controls of our experiment. Second, the concentration of inhibitor does not saturate all the enzymes. We will first show a situation with a lower concentration of substrate. As you can see in this model, some of the inhibitors have bound to the enzyme. In this image, we also have most of the substrates bound to enzymes without the inhibitor. This is because we assume that substrates have an affinity to bind to enzymes without non-competitive inhibitors. Thus, there is going to be an increase in product concentration and increase in the rate of product production, indicated by the positive slope of the graph. Now, we will show an increase in substrate concentration. We can see that while we increase the substrate concentration, there will not be a large increase in product concentration. This is because when we increase the substrate concentration, while the substrate can bind to the enzyme inhibitor complexes, this does not increase product concentration, because when the substrate binds to form the enzyme substrate inhibitor complex, also known as the ESI complex, the ESI complex is not able to produce the product. Thus, we can determine that the maximum product concentration, or the plateau, for an enzyme-catalyzed reaction with the presence of a non-competitive inhibitor occurs much more quickly compared to non-inhibitor and competitive inhibitor graphs. Finally, we can make the substrate concentration past saturation. We can see that while we increase the substrate concentration, the graph will continue at the same product concentration, thus meaning that the rate of product concentration and the slope of the graph is zero. So we can determine that the maximum product concentration, or the plateau, for an enzyme-catalyzed reaction with the presence of a non-competitive inhibitor occurs much more quickly compared to non-inhibitor and competitive inhibitor graphs. Finally, we can compare the non-inhibitor product concentration graph and the competitive inhibitor product concentration graph, as well as the non-inhibition product concentration graph. We can firstly see that the non-competitive inhibitor has a higher slope or rate of product concentration than the competitive inhibitor and a lower rate of product formation than the non-inhibitor graph. But we can eventually see that the competitive inhibitor rate of product concentration becomes higher than the non-competitive inhibitor rate of product formation, because the non-competitive inhibitor rate of product formation plateaus or reaches its maximum product concentration much more quickly compared to both the non-inhibitor graph and the competitive inhibitor graph. Furthermore, we can observe that the rate of product formation with the presence of a non-competitive inhibitor is substantially lower compared to the product concentration for the competitive inhibitor and the non-inhibitor graph. The reason why it is so much lower than the competitive inhibitors is that while the enzymes can only have the competitive inhibitor or the substrate bound to them, the presence of a non-competitive inhibitor means that the enzyme substrate inhibitor complex, or the ESI complex, can be formed. Thus, while in competitive inhibition, if a substrate concentration was higher than saturated and there was a higher saturation of substrates versus the inhibitors, it would lead to a higher probability of the substrates binding to the enzymes rather than in the inhibitors. On the other hand, the non-competitive inhibitor can form the ESI complex, which means that a higher concentration of substrate will not necessarily make it more likely for the ES complex to be formed and thus the product to be formed. So thank you very much for watching this video, and in our next and last video of the graphs of product concentration, we will be discussing uncompetitive inhibition. See you then.